Hello everybody. This video is the second part discussing derivatives. Now, the first video talked about finding the derivatives of a function at a given point. This video is going to discuss finding the derivatives of a given function for the entire function. So, it might sound more complicated, but it's not that much different. So, for finding the derivative of a function as a whole, there's only one real difference. So when you were evaluating the derivative at a point, you were using a in the derivative setup. But now we'll just have regular x. Now, while it's useful to be able to know how to do both, keep in mind, for a derivative to exist as a whole, it requires that it has to be continuous everywhere. So if a function is not continuous at a given point, it will not have a derivative at that point. Now, the converse, if you can find the derivative at a given point, that does not mean the derivative exists for the whole thing. And be careful of that. So, you've all seen this, but with a's instead of x's. So it's not that much different. Issue here is you won't be able to simplify things as easily, but it's still not too bad. Now, when you solve for this, it has to be true for all x values. Now, you want to make sure the tricks we used for using limits get used here as well. So, when h is approaching 0, you want to check from the left and from the right to make sure it stays the same from both directions. So let's take a look at this example. If you want to do it yourself, feel free. Go ahead and pause it. I'll give you a second. All right. Hopefully those who paused it have come back and are now seeing how they did. So consider the function k of x is the absolute value of x. Everybody should be familiar with this, but if you're not, the absolute value changes what the entirety of the inside to a positive. So if you have x minus 2 on the inside, it does not change that to an x plus 2. You would evaluate the entire thing and then change the sign. So if you follow these steps, and let's say we're doing it at 5 again, like we did for the previous video. When you put that in, you get something nice. When you evaluate it, well, if h is less than 5, in fact, less than negative 5, you'll find it comes out pretty nicely. So at almost any point, we could say that we have our nice derivative. Now let's find it at 0. So if you put that in, you get basically the absolute value of h over h, which, you have to keep in mind, if you look at the limit table, if h is negative, that's going to be a negative 1. If h is positive, it's going to be a positive 1. So that means it does not have the same limit from either direction, so the limit doesn't exist. Therefore, the derivative does not exist at 0. So while this does have a derivative most everywhere, at 0 it does not, even though it is continuous there. So that's something you have to keep an eye out for. So here's an exercise for you to try. So take this same function, the g of x that we had before, but let's just call it f of x. X squared plus 2x minus 3. I want you to find the derivative. So I'll pause it and let you go ahead and try it. All right, hopefully you've tried it. The basic setup doesn't change regardless of what type of problem you're doing. Just make sure you put the x plus h's inside parentheses. And you also want to make sure you have parentheses for the last part getting subtracted, because its signs all change on it. Then we have simplified version, which you're able to pull out h out of everything on the top. So that h will cancel with the 1 on the bottom, which leaves us 2x plus h plus 2, and h is going to 0. So we get 2x plus 2. All right. Now let's try this problem. So find the derivative of the function g of x equals x plus 2 over x minus 3. This one's a bit more complicated because it does require finding a common denominator. Setup, still the same. Now, you have to remember to put x plus h in for each part, top and bottom. Alright, hopefully you've tried that. We want to get a common denominator, so we multiply the left side by the denominator of the right, and the right side by the denominator of the left. So you have the x minus 3 over x minus 3 is coming from this, and the x plus h minus 3 over x plus h minus 3 is coming from this. Alright. We can pull the 1 over h to the front, just so you can see things a bit better. When you multiply everything out, you get this. And I went and pulled the h back in on the bottom. After you cancel things out, it actually comes out pretty nice on the top. But you can see there's an h on the top, h on the bottom. They cancel out, so you get negative 5 over your denominator. Now, your limit is still going as h goes to 0. So if you've set h equal to 0, nothing bad happens, so you should be good. All right, see you in class.